Okay, so here are some supplemental problems for section 10.3. So the first problem here is the theorem that if you've got two congruent arcs and they're cut off by chords, the chords are also congruent. So I think we're just solving for x in this case. So set 5x minus 1 equal to 4x plus 3. Add 1, subtract 4x, x equals 4. Plug it back in. 4 times 4 is 16 plus 3 is 19, or 20 minus 1 is 19. Okay. Next, 16 and 17. You've got a circle. Okay. The radius is 14, so that means that AB is 14. And then you also know that CD is 22. So the question is to find each measure. Now the key to this is that you have a radius and you have a chord that's perpendicular to, because what that means is it's going to cut it in half. And so this is really 11 and 11. So the first one is, what is CE? Well, it's 11. The next one is, what is EB? Okay. And that's the one that's a little trickier, because we have to kind of, like, what we have to do is we have to draw in AC. And that's the one that people always miss on this problem, and that's what makes this one tricky, is I have to draw in the radii. And the reason is, I know that CE is 11. I can find AC is 14. What I'm really going to do instead of finding EB is I'm going to find AE. Because there's actually no way for me to get to EB specifically. But I can say, let's call this x. I can say x squared plus 11 squared equals 14 squared. Okay. So x squared plus 121 equals 196. Subtract 121. X squared is 75. Take the square root of that. X is approximately whatever the heck the square root of 75 is. On second square root 75. 8.66. It does say nearest hundredth. Okay. Now, if I just draw segment AB, I know it's 14, and I know that A to E is 8.66. Sorry, it's out of the screen, isn't it? So A to E is 8.66, so E to B has to be the rest, which is 5.34. 5.34. So that's a tricky one. It's probably the most tricky problem in the entire section, or trickiest problem. Okay, next one to take a look at, 22. Okay. We've got a circle. We've got congruent segments AB and BC. So here's AB, here's BC, they're congruent. DF is 3x minus 7. FE is x plus 9. What is x? Well, we have a theorem that says if two segments, okay, two chords, are the same size in a circle, they're the same distance from the center of the circle, which is what we're really using here. So 3x minus 7 has to equal x plus 9 because DF has to be congruent to EF. So subtract an x, add 7. 2x is 16. Divide by 2, x equals 8. Okay. And then last problem for this section to take a look at. Number 32. 32 is really a lot like the other ones, except for there's some overlap here. And the theorem is that if you have two chords that are congruent in a circle, which those two are, GH and KJ are congruent, they cut off congruent chords. So, or sorry, congruent arcs. So arc GH is congruent to arc JK. So the question is, what is really the measure of x? Well, that means that 83 has to equal 2x minus 27. So add 27, 110 equals 2x, divide by 2, 55 equals x. Okay, and there are just some extra problems from section 10.3.